continuity and differentiability. I don't know how far we'll get, but we can do questions, like if you have any questions on the multiple choice that pertain to these. Okay, so we're going to do limits. We didn't even get the continuity. We'll finish this tomorrow. How many of you are going to be gone tomorrow? There's something, I thought it was first base or something. Juniors. Oh, that's next week. Oh, well, that's good. Okay. And I've got the videos. They're all going to be up there, and you can look at last year's videos, too. It doesn't matter. It should probably be the same. And actually, I should have dated this here, April 11th. Okay. So we're going to start with limits. This is really Chapter 2. This is part of Chapter 3. And we'll review everything. Now, you probably forgot about limits. You probably forgot a lot about derivatives. Okay, what is a limit? If I say the limit as x approaches c of f of x, what is a limit? Let me draw a picture. As x gets close to this value here, I'm asking you, what is the function getting close to? That's all it is. So you know what a limit is? It's the y coordinate. That's all it is. And there are different kinds of limits. We can do limits at a point. We can do limits at infinity or negative infinity. And so we're first going to start with limits at a point. So do you remember what you have to do to find a limit? By the way, what is the limit of this graph? It would be L. The y coordinate. That's all it is. Now, I don't care what happens at C. That's not important. Continuity, it is important, but not on just limits. So, a limit, what should we always do first? Do you guys remember? We always substitute. And you get points for that. So if I ask you for the limit as x approaches 0 of 2x, what's the y value getting close to? It's getting close to 0. Okay, so there are 4 things that can happen. The first thing is you could just get a number. You know what the chances of that are happening? Slim to none. None. They're never going to give you something that easy. They want to see if you can do the work to figure out what's going on. You could also get 0 divided by a number, which is really the same thing. It's because what's 0 divided by a number? 0. You could get a number divided by 0, and that's a vertical asymptote. And the answer, unless you are being careful about it, you would just say undefined. And I've seen that in the free response section. What you're really going to be getting here is either positive infinity or negative infinity. And you have to check from both sides. We'll talk about vertical asymptotes soon, just not yet. Okay, Jack? Put that away. There's calculus in 20 minutes that's in YouTube, and it's actually pretty good. It goes really fast, but when I would watch that even before we do these study sessions, because it's just going to refresh your memory about what we did, and then you're going to have more questions in detail, but at least get you thinking, well, what did we do all year? And be proud of what you've done, because you've done an amazing amount of work. You should be really proud of yourself. Think about what you knew when you came in here and what you know now. It is. It's a lot. And you learned a little algebra, too. Okay, so we'll do that one. If the answer turns out to be negative infinity, you have the choice of writing undefined or negative infinity. I would go with the undefined. And I remember this on one of the tests. I said, find the limit, and you say it's undefined, you get full credit. If you put positive infinity, you are not going to get the point if it went to negative infinity. So if you don't want to figure out which way it goes, then just say undefined. That's the safest bet. And then the last one is 0 over 0. That is indeterminate. Keep going. That's right. And even yet, I've seen some of you stop. Don't stop. And I'm going to give you a little theorem today to help you with the 0 over 0. Didn't give it to you when we talked about limits because everything was so new and it was just one more thing. It's also not required for the AV exam. It's called L'Hopital's rule. And we'll do several examples. Okay. L'Hopital's rule says that if the limit as x approaches some value, some c value, of f over g, it has to be a fraction, if that's equal to 0 over 0, or infinity over infinity. So if that's true, then what you can do to find the limit is take the derivative of the numerator and the derivative of the denominator. It's not the quotient rule. This is a different theorem. That's the reason why I don't give it to you. And you're going to love it because it's easy, but I don't want you to use it unless it applies. You must have 0 over 0 or infinity over infinity. So as x approaches c, you can take the derivative of the numerator and the derivative of the denominator, and that will give you your limit. And actually, it applies more than once if you have to do it more than once. So let's do a problem. It's really nice when you start seeing these. Do you remember this limit? Anybody remember what the answer is? It's 1. Okay, Samuel? This is 1. And we memorized it, remember? Okay. Now, if you are asked to do a limit on the free response part of the exam, always substitute in and say what you get. So if we put 0 in here, we would get the sign of 0 over 0. What's the sign of 0? 0. So if you write 0 over 0, then the reader knows what you're planning on doing. They understand that you did that part. You understand limits, at least to some degree. If you didn't write that on the exam that I graded, you did not get full credit. But that was a BC. But they could still do this to you here. Okay, so we're going to use L'Hopital's rule because I do have 0 over 0. And all I have to do now is take the derivative of the numerator. It's not the quotient rule, just the derivative of that, which is cosine of x over 1. Go ahead and evaluate now. You can't keep doing L'Hopital's rule. You have to always evaluate. If you get 0 over 0 again, then you could use L'Hopital's rule again. So what's the cosine of 0? It's 1. It works every time you have 0 over 0. But do you understand why we didn't tell you way back? Because you had too many things to think about that were brand new. So we didn't want to do that to you. Let's do another one. It's even nice if you recognize a derivative. Actually, that's what this is. That's a derivative. But we can take it. You can either do it as a derivative or you can do it as a limit. The derivatives are limits. Okay. Do you remember what we did with this one? Well, first off, you put 2 in, you get 4 minus 4 over 2 minus 2, which is 0 over 0. Right? Always do that first. And then, do you remember how we did this? We factored this. X minus 2, x plus 2 over x minus 2. Okay, that's the problem right there. That's the 0 over 0. And remember, we don't care what happens at 2. So if we're close to 2, these are the same numbers. And we cancel those out, and then we substitute in 2, and we got 4 for an answer, right? Okay, let's use L'Hopital's rule. So you may do this. And the multiple choice, they're not checking your work, so you don't have to even worry about it. But you better check to make sure you get 0 over 0 or infinity over infinity, because it doesn't work if that's not the case. So it's the limit. Now, you don't have to write L for L'Hopital, but everybody does. And everybody knows this theorem, by the way. My BC kids love it, but the problem is they got some problems that were harder. You're not going to have anything harder than this, so that's good. So take the derivative of that one, which is 2x, and the derivative of this one, which is 1. What's the answer? 4. No, because it was going to be too much for you. Remember, you had all that limit stuff, so we decided not to do this, and it's not on the AB exam. But that's not to say that you can't use it on the AB exam. You certainly are allowed to. It will not be tested directly, though. Because you can do this problem this way or this way. It doesn't matter. Okay, let's try another one. This is the one I made up. I know you hated these. This is the limit as x approaches 4 of square root of x minus 2 over x minus 4. Remember those? You hated those, right? You multiply by the square root of x plus 2. Well, you can do that. Or you can use L'Hopital's rule. Do I get 0 over 0? That's the first question. Yes, I get the square root of 4 minus 2 over 4 minus 4. So it's 0 over 0. So we're going to use L'Hopital. So I have to remember how to do the derivative of this. Now, if this is a free response question and you're going to use L'Hopital's rule, you would actually, the best thing to do is to say, I'm going to take the derivative of square root of x minus 2. Because if I do it wrong, and at least tell the reader I'm going to take the derivative, then you get partial credit. Because honestly, there were students who took the derivative of 2 and left it at 2. What's the derivative of 2? 0. And we were shocked at how many students did that. The derivative of a constant, they kept the constant there. It was like, but you're in a testing situation. It's stressful. So this now is clear. I'm going to take the derivative of both the numerator and denominator. I don't have to say L'Hopital. I mean, I like to, but that was not required. But if you did that and then did the derivative wrong, you still got partial credit. Well, the only thing that's going to be a trouble here is the derivative of the square root of x. Well, that's x to the what power? 1/2. What is the derivative of that? 1/2 x to the, remember you're going down now, negative 1/2, because we just did all those integrals, right? Other way. Now, I found in the last class they really struggled with the negative exponents. What's a negative exponent? I can put this in the denominator and make it a positive exponent. Do you remember that about negative exponents? So if I have x to the negative n, that's 1 over x to the positive n. Okay, so it's the, I think it's 4. The limit as x approaches 4, that's going to be 1 over 2 square root of x. That's the derivative of the numerator. The derivative of the denominator is just 1. Easy. So this is equal to 1 over 2 square root of 4 or 1/4. That would be good enough on free response. But this would be a multiple choice question. So there may be some questions out of the 2008 exam with limits that you may have some questions on. But I'm hoping this has cleared those questions up. Yeah, we'll do those too. Let's see, I've got another, that was example 3. Let's do another one. I don't know if you remember this one. It's the limit as x approaches 0 of 1 minus the cosine of x all over x. Do you remember what that one is? No? It's 0. And I could multiply by 1 plus the cosine of x. Well, let's substitute 0, and it's 1 minus the cosine of 0. And if you need me to review the trig, you just let me know. What's the cosine of 0? 1. So it's 1 minus 1 over 0. It's going to be 0, the answer is. But let's go ahead and use L'Hopital's rule. So what's the, now if I wanted to be really clear about this, I'd write the derivative there, but not, I mean, I'm not going to do it wrong. At least I don't plan on it. What's the derivative of 1? It's 0. Minus cosine x, so the derivative is plus sine of x. And I could even do that wrong and still get it right. And the derivative of x is 1. plus the sine of 0? 0. So if I find some time where we have time in class, I maybe will review those trig values again, because we have to know. And if this were free response, you could leave it like this. Well, no, you can't do that, sorry. But you could leave it like this. You don't have to evaluate your trig functions. So if you get the sine of pi over 3, you can leave it the sine of pi over 3. Not on the multiple choice. Multiple choice, you're going to have to know what they are. Because it's a different intention of what they're testing for. Okay, then here's another limit that you must know. And somebody guessed it right in the last class. I was kind of surprised. Now, this is a strange limit. And there are going to be a lot of things people are going to think about. Like if x is going to 0, you might say, well, then that x doesn't really matter. So this is 1. And 1 raised to any power is 1. But honestly, that is not 1. That's a little bit bigger than 1. And any number bigger than 1 raised to a big, any number is going to go off to infinity. You take 1.0001 and raise it to the trillionth power, it will get infinitely large. So they're fighting each other. This is also an indeterminate one. Does anybody have a guess as who's going to win? It's not going to be 1. It's not going to be infinity. Someplace in between. There's a special number out there. That's a good guess. E.
Oh, yes.
Yeah, but you came up with E. That's good. So this one you need to know.
You just need to know that.
Yeah, you just memorize it. Because that may show up on the exam. So that's an important one, especially in the BC. I know that, but I'm not sure about this one. Okay, one last thing about limits. These are just regular limits. What has to be true for a limit to exist? Very good. For a limit to exist. Yes, we are. We are. The limit from the left of c, so x approaches c from the left, of f of x must equal the limit as x approaches c from the right. Now, this has been on the free response part of the exam the last 2 years, I believe. They ask you about continuity, which is stronger than this, but this is part of continuity, and you had to find the limit from the left. And you had to clearly tell the reader, this is the limit from the left, and this is the limit from the right. And either they're equal or they're not equal to make that claim there. So that's really important also. Oh, these are my doggies. You can't tell, but they are. You can make any creative pen you want with pictures, but they're so little. Yes, you get to meet the dogs next week. Okay. I think that was it on that part of limits. Now, let's talk about those other kinds of limits. These are the limits at a point. We're going to do the asymptotes. No, I don't want that one. So we have a vertical asymptote. Did I spell that right? Okay, so if you have a graph, it looks like this. This has a vertical asymptote. This is y equals 1 over x. This is the one where you get the number divided by 0. So it's when your denominator is 0, but your numerator is not 0. When you do this, you must look at the limit as x approaches c from the right side, because if we're talking about 1 over x from the right side, is what? What's this going up to? Positive infinity. The limit, and make sure you write your letters carefully too. Because I know one year one of the students wrote it like it looked almost like an 8, and so they marked it wrong. So we have to be able to read it. If there's a question about whether or not I can read something, I'll go over here to Jack, say, Jack, will you read this? See what you see. I won't tell him what I'm thinking. I want to hear what he's going to say. We try to be as fair as we can. And if we, the two of us, can't figure it out, then I go to the table leader. What about this one? Where's that going to? Negative infinity. So when you get the vertical asymptotes, it's either going to go to positive infinity or it's going to go to negative infinity. That's when you get the number divided by 0. So those are all limits at points. If you get a number, that's great. That was easy. If you get a number divided by 0, you're talking about a vertical asymptote. If you get 0 divided by a number, that's just 0. And you get 0 over 0, then you got to do some work. Can a function cross a vertical asymptote?
No.
Why not? What's wrong with that picture? Doesn't pass the vertical line test. It's not a function. That's the reason why a function cannot cross a vertical asymptote. So can you cross a horizontal asymptote? Yes, because you still have a function. It's the only reason why you can't. Okay, so these are always going to give you positive infinity or negative infinity. If you don't know or don't want to figure it out, just say undefined. It just depends on the nature of the question. Okay, now let's do horizontal asymptotes. These are end behaviors. We want to know what the function's doing way away from the origin or way away from any particular point. So this is the end behavior. I don't really care what's happening at the origin. So this is the limit as x approaches positive infinity of f of x, and the limit as x approaches negative infinity of f of x. They might be the same, they might not be. That's the problem. Polynomials are going to behave nicely. They're probably going to be the same. Remember what polynomials are, Jack? Remember, this is for you, not for me. Polynomials look like x squared. Those behave nicely, but if I get exponentials, then all bets are off. All that stuff you learned about HOV, if the exponent is bigger on the top than the bottom, that only works for polynomials. It doesn't work for any of the other ones. It doesn't work for this one. The limit as x approaches infinity of the sine of x over x. That's different than the 0, isn't it? We got to read it carefully, because even I would sit there. I've read that wrong. Oh, it's infinity. Well, what's happening to the sine of x? As x gets larger, is it going to any particular value? No, it's going back and forth between 1 and negative 1. So the biggest this will ever be is 1. The biggest this denominator will ever be will be huge. So like 10 to the 20th power. So what's that getting close to? 0. It's oscillating, true, but it still has a horizontal asymptote of 0. So that would be y equal to 0. So be careful when you read your limits that you read what x is getting close to, because even I've made that mistake. It's easy to make. Very easy to make. Okay, let's do a problem. Let's do number 19. See if I can remember it. Off the 2008 exam. That's the one they threw out. But I think they're going to come back and do it again. I think it's 5 plus 2 to the x over 1 minus 2 to the x. And they ask for all the horizontal asymptotes. Here's why I think they threw it out. 2008, multiple choice, number 19. You should have it. This is the non-calculator. Whoops, that's 2003. You got this Monday. Oh, here's my... No, you got it Monday. If you are missing one, I've got them. I've got more here. we can look at some of these multiple choice questions. Yeah, if you were absent, grab them. I'd rather really stop in the same place as I did in my other class, otherwise I'll have to remember where I stopped. Okay, to do this, see the problem is most students probably did this. They took the limit as x approaches positive infinity of this function. Now, you can, on your own time, graph it so you believe what it looks like. I don't know what it looks like, but I do know what the end behavior looks like. Now, let's put in numbers. These things with infinity are really hard to deal with. Let's try x equal to 100, and let's see what happens. Then it's going to be 5 plus 2 to the 100 power over 1 minus 2 to the 100 power. Now, if this is my money in my bank account, I don't really care about the $5. If I have 2 to the 100th power, that $5 is meaningless to me. Same like when I go to Egypt and I tip, if I tip an Egyptian dollar, it's worth 15 cents. What do I care? Even a regular dollar, I would tip them sometimes a regular dollar. And it was like they hit the lottery, won the lottery, because that's a lot of money to them. $1 American is a lot of money to them. So I don't really care about my single dollars, my $5 over there. So they're not going to matter. They're going to just affect those functions just a little bit. So this is approximately 2 to the 100th over negative 2 to the 100th. What's that getting close to? Negative what? Negative 1, because it's really this, 2 over 2 to the 100th power with a negative out there. See, that's the problem. Y equals negative 1.
Okay.
That's part of the answer. But see, here's the deal. You see A, you find that answer, I'm done. Don't do that. Read through all the answers before you make your decision. And I think that's why they threw it out. I think there were a lot of students who got A because that's all they looked at. A is not right. This is number 19 on the 2008 multiple choice. Yeah, let's try the negative 1. See, that's what they're saying. You must look at positive infinity and negative infinity. And I think when you're dealing with infinity, and especially with exponentials, it's kind of nice just to put a number in there. There's no rule. You have to think. Okay, so this is, well, let's try x equal to negative 100. So it's 5 plus 2 to the negative 100 over 1 minus 2 to the negative 100. So that's 5 plus, what's 2 to the negative 100? No? Well, yeah, it is. It's going to 0, but what is it so you can see it? It's 1 over 2 to the positive 100. Is that okay? Yeah. Well, we had some problems in the last class with that. And then this was 1 minus 1 over 2 to the 100. Well, if you take $1 and divide it by 2 to the 100th power, what is that getting close to?
0.
That's 0. That's 0. So what is this getting close to? 5.
Oh, that's hard.
Well, you have to always look at both positive infinity and negative infinity. So there's not always just one horizontal asymptote. There can be another one. And so the answer is E. And the other ones that the kids got, they got C because some of them did the negative infinity but didn't do the positive one. And they're saying even the students who got 5s didn't do well on this. But I don't know why they threw it out. But I guess they just felt it wasn't fair. No, they're yours. Okay, I don't know if there's other ones you want to look at. That does everything we want for limits. And were there any multiple choice questions that you would like to ask me about? Let's see. Oh, how about number 1? Number 1, I think a number of you got wrong. This is a 2008 number 1. This is a limit. Now, this is one of those horizontal asymptotes. And honestly, I do the problem And if I don't know what to do, maybe I'd look at the answers. All I care about, when these are polynomials now, all I care about is the leading coefficient when they're polynomials. And the leading coefficient is going to be the product of negative x and 2x. So that's going to be the limit as x goes to infinity of negative 2x squared. And then these are going to be lower exponents, so they're not going to matter much. If x gets big enough, and this is x squared, and we could FOIL that out easily if we wanted to. But that's looking like negative 2x squared over 1x squared. So that's equal to what? Negative 2. And that should be one of my choices.
Yeah.
Where's my test?
Try that other one then.
Yep. Number 3. Okay, the problem with 3 is, and I might as well just do it right now, is simplifying this. And I've never shown you, because there was never anything in the book that looked like this. There is in our old book. Okay, I want to find the derivative. So we're going to use the product rule. No, I'm not going to expand that. So F, because it's too hard, it would take too long. Remember, you get not very much time, 2 minutes a problem. So it's the first one times the derivative of the second. And this would be one I wouldn't spend a lot of time in, because it's only 1 point, and there's a lot of work. Okay, so it's 3 times x squared plus 2 to the what power now? Second. Do you remember the chain rule?
Yeah,
Times 2x. Excellent. That's really good. Plus. And it's x squared. Yeah, but when you see the trick, you're going to say, I wouldn't have thought of that. Okay, that second one times the derivative of the first, which is 1.
Yeah, I got that.
Now,
Let's see what.
that's good, because really I think that's what they were testing. But they're testing algebra here. I'm not going to multiply that out. I'm going to factor out common factors. So I'm going to factor out that and that. Now, I got to get the most I can get out of there. What's the most I could factor out? 2. Like I said, we didn't really have any problems like this. So I think this is a hard problem. So it's x squared plus 2 squared. And you could look at the answers maybe and figure it out from there. And then I'm left with 3 times x minus 1. Right? Oh, times 2x. Missed that one. And there's still one of these still left here, x squared plus 2. So could we rule out some things fast? We know we're going to have x squared. It's either going to be C or D. And without even doing any work, I know it can't be C. Yes, this is from here. Thank you. There was a parentheses missing. Parentheses. And it messed her up. That's the problem. So I don't need to multiply that out. You can see why it's going to be D. I can see it from the plus 2, plus I have an x squared. I want to have a 6x squared. So that's 7x squared. So you can rule out some answers. Now that's the reason why we give you the multiple choice test with the answers is also to teach you some some test taking skills. Yes. And so you don't have to finish the problem to get the problem correct. We're talking about saving time. Oh, there's a limit on number 5. Let's do 5. Oh, you guys did it? You could factor it, or did L'Hopital's rule work right away? If it doesn't work right away, then you have to do it again, but you have to simplify first. So do you want to do L'Hopital's rule? Just to practice it? I'd factor it personally.
Can you just take the ratio?
Of the derivatives. This is 0 over 0, right? So if we use L'Hopital's rule, it's the limit as x approaches 0. Sometimes it's not the greatest thing in the world. This is what? 20 x cubed plus 16x over 12x cubed minus 32x. Do I still have 0 over 0? Yes, I do. So guess what? We do it again. I don't know how many times. This is 60x squared plus 16 over 36x squared minus 32. Now put 0 in. You get 0 over 0? You get 16 over negative 32, negative 1/2. A. Do you want to see the factoring way? Or you like this way?
That way.
Now, on number 6, let the f be the function listed above. Which of the following statements are true? I never look at the answers on this one. Now, we haven't talked about continuity or differentiability, but first let's do the first thing. Here's f of x. You can do part of it, and maybe you remember continuity. We'll do those and differentiability tomorrow. And we probably will do some free response. So bring your packets. Okay. The limit. Now, for a limit to exist, the limit as x approaches 2 from the right must equal the limit from the left. Now, if the limit doesn't exist, then it's not differentiable and it's not continuous and you're done. Nothing. So this would be the first thing I check. Well, the limit from the left equals the limit from the right, doesn't it? What is the limit? It's 4 because we just did that problem. Okay, so that's true. Is it continuous? No, do you remember continuity? The limit has to exist, but the value of the function must equal the limit. Is it continuous? No. This looks like the line x plus 2, except at 2. It's going to look like this, except at 2 there's a hole there, and that value is at 4. But unfortunately, they fixed the problem, but they put it at 1. That is not continuous. So if it's not continuous, you can't take the derivative either. So the answer to one that's true is 1.
I had it right the first time, then I focused on it.
So it's A.
Yeah.
So what I do with these is I write down on there, A is, 1 is true. Then I'll do 2, and 2 is false, and 2 is false. 3 has to be false as well. Then I can match my answers down here. Because if you're like me, it's kind of hard. Okay, so look through the limit problems in your packets. We haven't done the continuity piece, but we'll do that tomorrow. So I know there was a continuity piece in 2012, and I think 2011. So we'll look at those tomorrow. It's time to go. Study out. If you can do a half hour outside of class, you'll ace this exam.
No, wait. Yeah, positive.